is Sarah Martinez, and I am your host for this podcast called Forensic Files. The topic I will be going over today is from Learning Module 6, Discussion 12. The assignment was to try to extract a sample of our DNA and try to observe it without a microscope. It was a more difficult project in terms of understanding and following the directions, but once completed, I think it was all worth it. It began with placing a tablespoon of salt into a cup and gargling that water for 1 minute. This was the most unpleasant part for me, as I don't think anyone really likes the taste of pure salt in their mouth. But oh well, I got over it, and I swished the salt water back into the cup. Then we had to add a couple of drops of dish soap and stir very gently, or else the DNA would become unidentifiable. And this, of course, was the most nerve-wracking part for me, as I stirred as softly as possible. Next, we added freezer-stored rubbing alcohol with some blue dye in it and waited 3 minutes. At first, I was really worried because I was not seeing any results, but after letting the cup sit for a while, I came back and finally saw the strings of DNA formed. DNA is the code of life, so it was very cool getting to see that in person right in front of me, rather than, let's say, in a lab setting or through a microscope. It was one of the few projects in this class where we could get physical results, so it was exciting getting to show it to my parents and take pictures of the study. Now, I'm going to move on and discuss a famous crime that goes along with what we've learned in Module 6 of this course. In what is most likely the most famous case of DNA from an ancestry site being used to solve a crime, the infamous Golden State Killer was caught in 2018, more than 30 years after he stopped a spree of rapes and murders that left 13 victims dead. During his original crime spree, the Golden State Killer was known by several names, including the original Night Stalker, the Visalia Ransacker, and the East Area Rapist. It wasn't until 2001 that DNA evidence was used to confirm all 3 of those criminals were the same guy, who had originally been committing his acts in the 1970s and 80s. In 2018, law enforcement took the novel step of looking to genealogy websites to find a match to the DNA they had on file. Using the databases of genetic material uploaded by people who were just interested in finding out about their family history, they were able to score some partial matches. That meant people who were genetically related to the killer had used the services before. A family tree was made to pinpoint the killer that consisted of 1,000 people. The tree was then trimmed by getting rid of people who were the wrong age or lived in the wrong part of the world at the time of the deaths. In time, only one name was left on the list, which was Joseph James D'Angelo. The former police officer was arrested and charged with multiple murders. He took a plea to avoid the death penalty, and at age 70, the Golden State Killer was given 12 life sentences with no parole. This is just a glimpse into how DNA analysis has changed the course of solving crimes, and just how important it truly is for the procedures taken to extract and preserve any ounce of DNA found at a crime scene. Our final topic for today's podcast will be a current event article that correlates to both DNA analysis and bloodstain investigation, which is also something we have recently learned about and done an assignment on. The news article is titled, How Bloodstain Tails Can Point to Significant Additional Forensic Details, which this news is from the ScienceDaily.com, and it was published on November 21st, 2023. Forensic science has captured the public imagination by storm, as the profusion of true crime media in the last decade or so suggests. By now, most of us know that evidence left at a crime scene, such as blood, can often reveal information that is key to investigating and understanding the circumstances around a crime, and that scientific methods can help interpret that information. In Physics of Fluids by AIP Publishing, a group of scientists from Boston University and the University of Utah, led by James Bird, demonstrated how bloodstains can yield even more valuable details than what is typically gathered by detectives, forensic scientists, and crime scene investigators. By examining the protrusions that deviate from the boundaries of otherwise elliptical bloodstains, the researchers studied how these tails are formed. In fact, previous studies have primarily focused on larger blood drops falling vertically on flat surfaces or on inclined surfaces where gravity can reshape and obscure the tails. By contrast, the new study involved a series of high-speed experiments with human blood droplets with diameters of less than a millimeter impacting horizontal surfaces at various angles. The tail length can reflect information about the size, impact speed, and impact angle of the blood drop that formed the stain. When measured for several bloodstains in a stain pattern, the trajectories of the drops can be backtracked to their presumed origin. While their analysis employed only horizontal surfaces to examine impact velocity dynamics, Bird and his colleagues hope it triggers more studies that focus on the length of the tail in bloodstain patterns. They believe that incorporating tail length into standard bloodstain analysis will produce more robust evidentiary information. Knowing the origin of the bloodstains at a crime scene can help detectives determine whether a victim was standing or sitting, or help corroborate or question a witness's testimony, said Bird. Again, this is a wonderful demonstration on how important and essential DNA is to a crime scene, as it can be used to identify criminals with incredible accuracy when that biological evidence does in fact exist. Cold cases from 50 plus years ago are now able to be solved thanks to the advances made in this forensic technology. Thank you very much for listening to Forensic Files, and I hope it has been both a fun and educational time. Remember to stay curious. References and links for both the famous crime and the current event article can be found below in the description box.